We will study now ICMP, that is Internet Control Message Protocol. Internet Control Message Protocol. Okay, and it is nothing but it is network layer protocol. Okay, you already know this is nothing but it is the network layer protocol. Okay, so you have to keep in mind that ICMP is a network layer protocol. Okay, and what it is used, it is designed to overcome the two problems for IT protocol. That is, in IT protocol we cannot, there is no error reporting or correcting, and IT protocol lacks of mechanism for queries. So we can write that designed to overcome the following two problems. With IP protocol. What are those? Number one is there is no error reporting or correcting. No error reporting or correcting. And another is lacks a mechanism for queries. Okay, for queries. So two things sorry, no error reporting or correcting and lacks of mechanism, and these two things are basically missing for IP protocol. So ICMP is designed to overcome those protocols. Okay, and let us see, basically ICMP protocol is not directly passed to the from network layer to the data link layer. Rather, this message is first encapsulated inside the IP datagrams and then sent to the lower layer, that is data link layer. So let us see how it is there. So if you construct like this way, it is first there is an ARP. So there is an ARP, okay, and this is nothing but IP protocol, and here this is somewhere ICMP. Okay, so this is encapsulated inside this and sent to the lower layer. So we can write that ICMP messages are not directly passed to the data link layer. Instead, the message first encapsulated inside IP datagrams before going to the lower layer. Okay, so ICMP messages are not directly passed to the data link layer. Instead, the message first encapsulated inside the datagrams before going to the lower layer. Okay, that is data link layer. And let us draw one figure. Okay, just hold on. Yeah. Now let us draw one figure. There is nothing but first this is ICMP message, okay, and it is encapsulated with IP header, and IP data. This is a packet format. Next, this is nothing but frame data. Frame data. This is the your frame header, and this is the trailer. Okay. So ICMP message, it is encapsulated in IP header and IP data, and frame header, frame data, and trailer. So this is nothing but this way this is done. Okay. Now what is ICMP messages? Okay. So let us now discuss about ICMP messages. Okay. So first one is error reporting. Okay. So what is error reporting? It is nothing but report problems. It report problems that a router or a host may encounter while processing a IP packet. Okay. So report problem that a router or a host may encounter while processing of IP packet. Okay. And next one is query. So first one is error reporting, next one is query. So what is this? To fetch important or specific information from a router or host. Okay. So to fetch important or specific information from a router or a host. From a router or host. So let us say it is capital. Okay. So two messages are there. One is error reporting and another is query. So what is error reporting and what is query I have discussed over here. Okay. Now let us see what is the ICMP message format. Okay. So ICMP message format. So we have to remember this. So I will discuss it. So let us first draw. First it is type, and 8 means it is of 8 bytes. So what is the type? It is message type. It is either error reporting or query. Okay. And next is code. It is also consists of 8 bytes. So I write 8 bits. It's not byte, 8 bits. So this code is nothing, reason for message type. Okay. And finally this is a checksum. Okay, what is checksum? It is error checking for it is nothing but error checking. Okay. Next is rest of the header. And the rest of the header means for each message type. Okay. And finally it is data section. Okay. So what is this data section is? Find the original packet with error if there is an error message, or it has some extra information if it is for query. Okay. So let us first write, that is what is the okay, first I write the data section. So it is nothing but find the original packet with error. So find the original packet with error if this data section is for error message. So if for error message, so this is one part. If the data section is for error message, it will find the original packet with error, and if it is for suppose query, so it will for extra information. Okay, if it is for query, so it may data section may consist two part, for error message and for queries. Okay, and rest of the header, it is nothing but for each message type. This is, you can write this part is for each message type, for each message type. Okay, and this checksum is for error checking. Okay, now remaining two are type and code. So I write over here type, it is of 8-bit. Okay, so type is message type. So what kind of message type? Either it is error reporting or query. So error reporting or query. And finally is code. Okay, code is nothing but reason for message type. Reason for message type. So this is the format, and I have discussed all the internal things of the format with this diagram. So type, it is of 8-bit, so it is for message type, either it is error reporting or query. Next is code, it is for reason for message type. Next is checksum, it is for error checking. Rest of the header for each message type. Data section may have two parts. If it is for error message, it will find the original packet with error, and if it is for queries, there will be some extra information. So this is overall idea of ICMP message format. Okay, next we will discuss about error reporting message. Okay, so it will consist of basically two parts. I will divide this particular error message reporting message in two section. Okay, so first let us begin with what is error reporting message. Okay, so error reporting message. So what is error reporting message? So ICMP always report error message to the original source. Okay, but ICMP doesn't correct errors. Okay, so we can write that ICMP always reports error message to the original source. And you have to keep in mind that ICMP doesn't correct errors. Okay, and now we will find what are the messages. So we will study first two messages over here and remaining two in the next part of this particular ICMP part 2. This is basically we are doing for ICMP part 1. Okay, so first one, let us just study, and that is destination unreachable. Okay, so destination unreachable. So what is destination unreachable? It is nothing but whenever a route to the destination is not found and datagram is discarded, and the router or the host send destination unreachable message to the sender, okay, or to the source. So first I just draw the figure, and next we will do the theory part. So this is the source. Okay, now this is some router is there. This is the router, and this is the sender. Okay, sorry, this is the destination or the receiver. Destination. Okay, and suppose a message is sent from A to this router, but somehow this router doesn't have the necessary information or we cannot found the destination. So what we will do, it will report an destination unreachable message to the source. So it will report and destination unreachable message. So it will suppose there is no, it could not find this destination, this router could not find this destination. So in that case, when a message is intent to go for A to B via router, this router, so and if this B destination is not found, so it will send the destination unreachable. So this message is nothing but it will send to A that destination unreachable. Okay, so this is nothing but destination unreachable. Okay, and apart from now about the theory part, we can say that whenever a route to the destination, so I write over here, sorry, whenever a route to the destination is not found, okay, datagram is discarded. Datagram is discarded and router or host it may be router, it may be host, whatever may be, sends destination unreachable message, destination unreachable message back to the source, okay. So suppose this destination unreachable message will send to the source, that is A. Next we will study about source quench. Okay, so just next we will study about the source quench. This is the second, that was the first, is the source quench. So what is the source quench? So suppose this message informs the source that a datagram has been discarded due to the congestion. Now let us first draw what is basically happening from A. This is nothing but this is the source. Okay, so first the message is sent to the router. Okay, and from here it is connected with several CD, all this. Okay, so these are all connected to some host, but it found that there is a congestion in the network. So it will do what? It will send the destination, this message will send the destination unreachable to the source. Okay, so it will send this message to the source. So regarding the theory, we can write that this message, that is source quench, this message informs the source that a datagram has been discarded, that a datagram has been discarded due to congestion. Okay, so this is nothing about the source quench. Now in the next video we will talk about the time exceed. Okay, that is, it is generated in the, we will see that it will generate in the two cases. One is that code 0 and code 1, and we will study what is code 0 and code 1. Also fourth point is the parameter problem, and the fifth point is redirection. These all will be discussed in the next video. Apart from these three, we will also study about ICMP query message. It has two parts, that is echo request and reply, and another is timestamp request and reply. So we will study all these things in the next part of this ICMP protocol. Okay, thank you.